call it as a dicky, but in automotive terminologies, we call it as a deck lid. This is one of the very huge component. As you can see, it is having a many feature. It's having a so many feature. So to complete it, to do this, it will take so many hours to finish this meshing. So instead of that, I'm going to take one critical area. So I'm going to showcase everything, like how to do the meshing, how to carry over the meshing, or what are the geometry criteria we need to look into. We need to look when we are before starting the meshing. These are the contents of our course. First, we are going with the editing the geometry. Since HyperMesh is not a design tool, it is a CAE tool. So we need to edit the geometry as per our requirements. See, the designing is done by the other softwares, other designing tools, CATIA, Unigraphics, something like that. So we need to edit in the sense, I'm not going to change the CAD. I'm not going to alter the CAD. Just I'm doing, or I'm just creating or deleting the surface within the boundary of the geometry to create the elements. We are not supposed, being a CAE engineer, we are not supposed to change any dimension or any features or anything in the geometry. Just we can play with in the dimension, in the unit size, instead of if the design engineer has done in a millimeter, we can do it in a meter also. So in things like that, very simple manner, the CAE engineers works. But really, if it is required to edit the geometry, so what are the things we need to do? That so those comes under in editing the geometry. Then extracting the mid surface. Since we are interested to create the 2D elements, directly we are not going to create the elements on top of the geometry. We need to extract the mid surface. So let's discuss why it is required. Then the topology refinement. The topology refinement, basically it is a geometry cleanup. After creating the mid surface, what are the geometry features to be there, it is what are the geometry which are not required for our meshing, and why it is not required. Then we'll create the elements by using an automesh. What is an automesh? After creating the elements, does it really require any editing? That is the remeshing option. If it is required, how to do that? So how to carry over the final mesh, and if any additional checks for the 2D elements. These things we are going to discuss in the today's session. So we'll do one by one. I hope you already downloaded the HyperMesh softwares and you already received the file which I'm going to work today. It is good to know you already received the file also. Then you can start working with me to start your first 2D meshing using HyperMesh. Then before starting my session, I just want to give the information about what is a finite element method. In our colleges, we have learned what a finite element method, the subject was there. Few of them have studied the advanced version of the finite element analysis also, but the same theory will work in the software side also. Finite means it is a calculated number. Finite, see, I'm not, see, for this circle, it is having an infinite numbers. Here, I cannot define my formulas or equations, or even I cannot apply my software rules, my software thumb rules also for this circle. Even the academics formulas also you cannot apply when it is infinite numbers. So how you will define the equation for an infinite number? So what we can do, what the software is going to do means, first it will divide, like it may divide it in the nodes, or it may divide it for the points. So using that one, so how it is going to divide? How many lines it is going to divide? Whether it is by 3, 4, or n, till n we can go. N means infinite, before the infinite number we can define. For anything we can define it. So what I'm going to do, I'm making this circle from infinite to finite I'm making. So how I am making? I'm going to make this using a nodes and elements. See, these are the nodes. You can see the corner of the triangle. These are the nodes, and the entity of joining the nodes is called elements. This is what I have mentioned. Any continuous object has an infinite degrees of freedom. When we don't know the degrees of freedom, we cannot define any analysis. We can do the meshing without the degrees of freedom also, we can do the meshing, but doing a simulation, definitely it requires degrees of freedom. And we know there are 6 degrees of freedom, 3 translation and the 3 rotation. Obviously, we need to fix it, or we need to let it free in any of the direction which is required. So without that, I cannot define or I cannot solve any problem in the software. So finite element method is basically a degrees of freedom from infinite to finite with the help of discretization. Basically, the discretization means dividing. How I'm dividing? Using meshing. So how I can do the meshing? Using nodes and the elements, I can do the meshing. So using the elements, see, the entity of joining the nodes are called elements. You can create it in a triangle shape or rectangle, square shape or hexagon, octagon. So these are the different shapes which are available in the CAE, which you can construct any kind of geometry, But for our convenient, we are going with the two basic shapes, that are triangle and one is a square. So these are the basic two shapes which we are using in CAE industry, and these two are sufficient to define any problem. These two are shapes which are sufficient to solve any kind of geometry. So this is the theory behind the finite element analysis. Then we'll move on to the original sector, that is the 2D machining. As you can see, this part, it is a very big component, as it is having a many features. These are called the ribs. See, these are the ribs, and these are the pockets. These are the geometry terminologies which we use in the industry. I'm speaking. If I show it in a HyperMesh, that would be better. Okay, this is a HyperMesh. This is a GUI of HyperMesh. If you open any HyperMesh, it looks like this. As you can see in the left top corner, it will show the version of the HyperMesh, which one you are using. I'm using 2021.1. The version, it means, okay, which is the whether it is using a older version or latest version, it will show. Then I'm using an OptiStruct. OptiStruct is in solver. See, these are the different solver that the HyperMesh supports. As an HyperMesh is a preprocessor software, it will support for the different solvers like Abacus, LSDyna, Nastron, PAMCrush. These are the other areas where the HyperMesh supports. And I'm interested to construct my meshing or my model or my like things in OptiStruct. So I have kept the solver as OptiStruct. And if you want me to talk about the icons of the HyperMesh, means these are the menu bars. See, these are the menu bars where you can do the activities to open the new file, saving the file, importing the geometry. See, these are the things which you can do. Importing the geometry means somebody has already created some file in other design tool. I'm bringing that. That means importing. Opening the file means I'm just reopening the file which is built in HyperMesh. Okay. Then if you want to open any file, see, it will ask which are the file format you want to open. The same import and export options which are available here also. And these are the view controls. These are the view controls where you want to keep any views. And these are the periphery icons of the HyperMesh, which are in the borderline. These are called periphery icons. And then it comes to the pages. These are the different pages where the different activities to be done using these pages. As the name indicates, it's a geometry page, means it's all comes in the surfaces, geometry, lines, line edit, or editing the CAD, all related to the geometry sector only. Then if it is a 2D elements, means how you can create the 2D elements using a ruled spline, or if you want to edit the elements, the quality of the elements. So as the name indicates, these are the different pages, and these are called the panels. And if you click on any panel, the one more window will open, that is a sub panel of the HyperMesh. And this is a model tree, as all our activities are going to done here. See, all our activities are going to done here. This is the model tree. Okay, this is the model tree, which will be having a components, properties, material details, load collector, load steps. What are the activities you are going to create in HyperMesh? Everything will be available in this model tree. And this is the entity, and this is called the entity editor. That means what is the name of the component, or color of ID of this one, does it having any properties or any other details related to the meshing. All the things will be available in the model tree, and you click on any of the specific component, and again the entity editor will open. In that entity editor, the history of the component you will get. These are the basic things you should know before you creating any meshing in HyperMesh. Then if you click on the D button in your keyboard, the display panel will open. See, I'm taking all the components now. See, this is the dead click component. Okay, here you can see by part is there. I'm going to keep it in a component view. See, there are the different views which you want to keep, component, property, or material. Here I'm interested to keep in a mixed view. Mixed view means just it will highlight the things which are supporting the supported surfaces or unconnected surfaces, or if any triple. If you are going for the mixed mode, no, like complete the geometry, what and all the geometry details it is having, everything it will be visible in the mixed mode. So it is preferred to keep in the mixed mode. See, these are the different views I said. See, if you want to keep it in the front view, right view, or isometric view, which is comfortable for you to work, you can keep it. As I said, these are the ribs of the CAD, whether it may be a triangular rib or a square rib or a rectangle rib. And these are the features where we are going to work on this. See, this is one of the critical area, or I can tell important area, which comes in the decklid. And these are the pockets. Where, see, you can imagine these ribs or these feature in any of the car. If not, you can you observe this CAD and you can go and you check. The same kind of geometry will be available, but it looks very tiny in the decklid. But those are very important to very important in the area of analysis. You can go and you can check your car. You will find these features. So this is related to the CAD. Then we'll go for the mid-surface extraction. So why to go with the mid-surface extraction means, as I said, if you want to create any 2D elements, we need to extract the mid-surface. Why? Because it is having two surfaces. See, I just go and I'll show. I'll mask the few surface and I will show. Okay, see, it is having a two surfaces. I have masked the top and the bottom surface. Top and the bottom surface I have masked. You can see there are two surfaces. So to create the 2D elements, we need to extract the mid surface. So directly we are not going to generate, or we are not going to keep the elements on the top or bottom surface. We need to extract the mid surface. To that mid surface, we are going to define the thickness. What is the original thickness that the component is having? Thickness in the sense the distance between top and the bottom surface. What is that particular distance, or whether it is having an accurate value. So that value we are going to define the mid surface. So 2D machine means we need to extract the mid surface. Okay, what are the prerequisites we need to do before extracting the mid surface means it should be having all the surfaces to be enclosed. Why? Because see, when I'm going to start the machine, see, these are the design engineers, he has created the lines. These are the lines which he required, but I'm not required for these lines. So what I need to do, I need to toggle these lines. This is called geometry editing. See, I'm not deleting any surfaces. I'm not altering the geometry. Just I'll edit the geometry as per my requirement. Why? Because this area, this is a very small area. I cannot keep my elements over here. This is very small area, so I need to toggle this line. So how to toggle? Go for the geometry page, quick edit. See, here the toggle option is there. You click on this one. Just it will suppress it. If you want, you can retain it by clicking the right button. By left button, if you're doing, it will go, and by right button, it will retain. But you can see some of the dotted lines are there. It is not gone completely. That means the original line, this is the line which is created by the original geometry. This is not the line which I have created. But if I create any line manually here, but I can toggle that one. See, this is the line which I have created just now. If I am toggling this line, see, if I unsplit this line, see, it will not show any dotted lines. So this is the difference between toggling and the unsplit line. Why I'm doing means there are the small areas I cannot keep the elements. Why? Because I'm concerned about the quality parameters also. Those things we are discussing in the later section. So the areas which are very smaller areas, I'm going to toggle this one. This is one of the very important geometry criteria we should think. Next, you can see here some red lines are there, but here it is a green line. Green line means it is sharing between the two surfaces. Red line means it is a missing surfaces or unconnected surfaces. If you switch on the points, you can see I have just switched on the points. You can see some gray points, gray dots. No, these are called points in HyperMesh. These are called points in HyperMesh. So how to fill the surface? I'm in the same quick edit panel that is available in the geometry page. Go for quick edit panel. Here the filler surface is there. See, if you click on any line out of these 4 lines, it will just automatically fill it. See, I'm just clicking on the filler surface, it is going to fill. This is one of the shortcut way to fill any surfaces. So what are the other ways that we can do means, I'm going the 2D page. 2D page, I'm using the ruled option. In this drop down, I need only the surface. In this, I'm choosing the lines. Choose the first line and the second line. The collector should be the current component. See, this is the collector, where you can see this is the current component collector, which is you can see it in the model tree also. This is my first line and this is the second line. Say create. See, it is created. So like this, you need to create all the areas. So one more option is you can go with a spline. That is also available in the 2D page. So choose the lines. Okay, so create. Okay, we can create these things. So this is the geometry editing criteria. Then if you go for the mid surface extraction, to extract the mid surface for this component, it will take so much time. And why? Because to do any of the mechanical things, or even for the designing also, even for the CAE also, the system configuration is very important. The component level, what you're working, if it is in a simpler level, obviously you will get a less time. But for this complicated component, it will take more time to extract the mid surface. So what I'm going to do, I'll start the working on the file which we have given. See, I'll show the mid surface extraction and all for this simple component. Okay. So now we'll do some geometry addition for this also. I'm going for the quick edit. I'll just fill the surfaces. And one more option we have learned just now, that is the spline option. So keep surface. I'm using only the surface. Why? Because I don't want any elements. Just choose the lines to create the surface. Say create. Okay. If it is not creating, go for filler surface again. Okay. It is. We'll try one more time. Say create. So why I'm doing this, why I'm doing the geometry correction means, just to have a better mesh. Just to have a better mesh, I need to do all these checks. See, we have created this one. Using the ruled option, I'm going to create this one. I'm just filling the surface. See, this is done now. So these are the basic checks you need to do before extracting the mid surface. One more I'm doing using the filler surface. I'm doing that is in the quick edit panel. See, this is done. Now our CAD is ready to extract the mid surface. Even though this is in a cylindrical geometry, these are the ribs. These are the triangular ribs. See, these are the triangular ribs. Okay. Now we'll do the mid surface extraction. The mid surface extraction is available in the geometry page. See, in the geometry page, go for mid surface. Here the mid surface is there. This is very important to do the 2D meshing. Here auto mid surface, we are asking the software to extract the mid surface. But in the second radio button, you can see the extraction option. These are the different options which are available in HyperMesh to extract the mid surface. Based on the geometry of the component, it will work. Some of the component having any of the more features or more areas, critical features, say for example fillets or any of the circles are coming. So for that we are going with the sweeps. If it is having a linear thickness, that means all over the component it is having only the same thickness, means we are directly going with the offset. We'll check one by one. Just come for the auto extraction. In the extraction option, I have kept offset, planes, sweeps. I have kept. Select the surface. See, I'm using a shift button. Just click on the shift and select the entire surface. And if I click on the extract, here in the left bottom corner of the HyperMesh, it will show how much percentage is done. For example, since this is in for this, it will get extracted in 1 or 2 seconds. So before only you can, I'm just telling, it will show the percentage, how much percentage is going to done. See, I'm choosing the surface. See, if you want to select the surface, you need to click on the shift plus mouse button, long press on the left button, then select, create one window and select this one. To rotate the component, control plus left button. Control plus left button means the component will get rotate. Shift control plus right button means you can move the component all over the GUI of HyperMesh. Control plus left button. For zoom in and zoom out, you can use the middle button along with the control key. Along with the control key, you need to use this one. So these are the basic shortcut keys. And the HyperMesh having from F1 to F12, there are the different shortcut keys as per the requirement. Say for example, F1 it will take you for the help window, F2 for deleting any options, F3 for equalizing the nodes. From functional key F1 to F12, there are the different options. Using and shift functional key to using shift plus functional key F1 to F12, there are the other defined, that is a predefined things, shortcut keys. You can make use of this one. So we'll go for mid surface. Choose the surface, just say extract. Here say 98% is completed. After creating a mid surface, automatically new collector is going to create in the model tree. Earlier we are having only the one collector or one collector component, you can tell. Now the mid surface component, the software itself, it will generate automatically. So this flag symbol indicates the geometry. This coordinate symbol indicates the elements. So just mask the, see, I've just click on this one. It is went off. Now this is the mid surface. See, in the earlier one, see, it is having reduce the transparency. See, it is having two surfaces. But after extracting this one, it is having only the single surface. On using for this surface, we are going to create the elements. Only for this one, we are going to create the elements. Since it is one more time I'm stressing, for 2D elements, we need to extract the mid surface. Using that mid surface, we are going to create the elements. So this is one option to create the elements. Meanwhile, the same option will work. See, this time I'll choose a different option. Choose the surface and extract the mid surface. This is done. I'm just reducing the transparency. This is the transparency button. You can increase or decrease. See, earlier, no, when we are using the offset plus planes, this was not there. Now, in this one, we have got a sharp corner. See, this is a sharp. Earlier, it was not there. So, as I said, the different mid-surface panel will work based on the geometry. First one, we have used sweeps, but we didn't get that sharp one. But if I'm going directly with the offset means it is going to exactly create one more surface in between the two main surfaces. Okay, see, it is going to create one new surface between the two. So I'm just adding the nodes. Say add. These yellow ones are called nodes in HyperMesh. Sorry. These are the nodes. This is a wireframe. See, this is a wireframe of geometry. You can keep it in a wireframe. This is the shaded mode. And this is a wireframe. If you want to visualize the geometry in a skeleton view, you can keep in this view. Or if you want to see it in a shaded mode also, if you want, you can keep this way and you can observe for any of the geometry corrections. So we have done with the mid-surface corrections. Next, after creating the mid-surface, see, this is how it will work. This is how it looks for the entire component. It is going to take time to extract to show the complete mid-surface. So I have already extracted the mid-surface. This is how it looks, and this is the area we are going to work. So next, now we have done with the geometry side. Let's move on to the element size. So what are the elements? What are the different shapes of elements are available in HyperMesh? As I said, we can use any kind of elements in CAE industry, but basically there are two main shapes that is sufficient to create any kind of meshing. That is one triangular element, one is quad element. Triangular element means this is a 3-corner element, as quad means 4-noded. And we know what are the linear elements or parabolic elements also. Linear element means only the, see, this is a first order element. The parabolic element means this is a second order element. That how you will calculate the stiffness matrix using the first order and the second order element in finite element subject. The same way we will use when it is in the first order element, the number of nodes are less, but the element count will be same, but the nodes are only the defined set of nodes. But when it comes to the parabolic element, that is one mid node going to mid node going to add in between the corner of the element. But the element count will be same for both the cases. These two are the shapes which is sufficient to create any kind of mesh for any geometry. Next, we'll go for the meshing. So what is meshing? Okay, what is the shortcut key to do the meshing? As you can see here in the AutoMesh panel, here you can mesh for the surface also, or else you can edit the elements also. So we'll see it in HyperMesh only. So this is my CAD. I'm just using the mid surface. See, the AutoMesh panel is available in functional key F12. If you go and click on the F12 button, this window will appear. Here where we are going to mesh the component. Here, as I said, see, these are the different options, but that option is only for the, either you go with the quad, or else you go with the triangles, or else you can go with the mixed mode only. Mixed mode means both the triads and the quads will come. This is for the current component, or the first order means, as I said, whether you want a first order element or second order element. And this is the surface we are going to choose. See, this is the surface you are going to choose like this. Like this, you are going to choose, or else in a single click also you can select the surface. You can single click also you can select the surface. So first we'll learn how to create one collector. See here the collector shortcut is there. That is a component. You can go by creating here, or else directly go here in the model tree. Just right click on here. It will ask you to create. What do you want to create? You want to create one component. Okay, component name you can define. That is a mesh I'm going to create. So the component has been created. See, after creating every component, the new component will come and appear here. The last component, the last created component will be the current component. See, every time if you create one more component, the new component will come and sit here. That means what are the elements I'm going to create? All the elements will come for this component. It will collect all the elements. Now we'll do the meshing. As I said, it is available in the F12 also, and in the 2D page, AutoMesh is here also. AutoMesh is there. So here also AutoMesh is there, and here I have kept some number called 3. So what it is? It is the element size. Using that element size only for this throat component, the elements are going to create. The complete component, I'm using the 3 mm of mesh. Based on this number only, it is going to work. So we'll just do how the quad element look and the triangular elements looks in HyperMesh. I have kept the mesh type. I have kept it quads only. I'm just taking this surface. See, I'm just taking the surface and asking to mesh. I'm using the 3 mm of mesh. I'm keeping my elements in the current component. This is the current component. I'm choosing it in a surface. Here the option is there called mesh. If you want to mesh, you can mesh. If you want to reject, you can reject also. Just I'm keeping with a mesh. See here, I can see only the quad elements. That means 4 corner elements I'm seeing. I'm not seeing any triangular elements. Or else we'll choose the different area. Okay. Same mesh, you can see. And here, no, if you want, this number is there, no, the 12 what you are seeing, you can increase or decrease the number. It is going to increase the node number. If I am increasing the node number means obviously the number of elements will be more. This is called density. This is called density. If you click on the left mouse button, it is going to increase, or else if you do long press, it is going to increase. For left button means it is going to increase. This is called density changing. See, how much number of nodes you are going to create, based on that only the elements, number of elements will be available. See, this is how it looks. Say reject. So now I'll use only the rectangular triads just to showcase how it looks. See, you can see only the 90-degree triads. This is how the 90-degree triad looks in HyperMesh. Okay. Then if you want to create the equilateral triangles also, that is also possible. See, this is the equilateral triads. That means the 60-degree triad. See? It looks like this. If you want, you can keep it in a wireframe. That is the skeleton view. Or else in the shaded mode also, you can keep. Okay, these are the different shapes. Sorry, these are the different way you can build it. See, basically, these shapes are based on the project requirement, the component you're working. Why? Because if it is an 2D meshing or if it is a plastic component or sheet metal component, we need to work with the mixed mode only. Why? Because to capture all the features in all the way, it is not possible to capture the triangular, rectangular elements. You can see the shape of the geometry is like this. If I ask my software to create only the quad element, means it is not possible. It will ended up with the one tri element. Why? Because the geometry is like that. It is not in the software control also. To overcome this one, the preferable way to keep the mesh type is mixed mode only. So for most of the cases, we are going with the mixed mode only. But if the requirement is for specifically, if they are saying, okay, you need to go with the quads, or for example, if the requirement of the project is crash analysis, you are going with only the quad element. If it is a solid geometry, or if it is a casting component, so we are going with the solid elements. If it is a plastic or sheet metal component, we are going to use the 2D meshing, that is the mixed mode. So these are the different ways you can use the elements. Now I think I have given enough knowledge on the element size. Then we'll start the meshing. First you choose the surface, say mesh. See, keep it in a skeleton view. See, this is how it looks. If you want, you can increase. If I'm increasing the, you see, if I'm decreasing one density, see one tria is there. Why? Because there is a mismatch in the density. There is a mismatch in the number of nodes. So it is going to have one tria. So if you make the even number of, if you make the same nodes, the tria will go. So like this, you need to mesh it. Then mesh it where and all you require. See, here it is coming like this. Then if you want to mesh for these ribs, select this one and mesh this. Okay, you can see this is one small element has come over here. But how to correct this one? How to correct this one means I'll go for, first I'll delete this element which is not required for me. See, I'm going to delete this element. Then I'll go for F3. I'll replace this node to here. Okay, I have replaced. Now what I need to do, I need to edit the mesh. That means I need to remesh it. So how to do the remesh? Then directly go for F12 panel only. In the earlier case, we have kept surfaces. Now what we need to do, now I'm switching to elements. Why I'm switching to elements means I need to remesh this one. You can go by selecting the element by element, or else by selecting the window also you can select and just say mesh. See, you just observe this is, see, two triads are there and two triads. See, one more thing I wanted to tell. Okay, mixed mode means we are not supposed to keep. Okay, I need 100 triads means 100 triads we are not supposed to keep. There is a restriction of triads. So for that reason, I am going to do the remesh. Remeshing means I am just editing the existing mesh. See, I'm just selecting the elements and I'm meshing this one. See, the two triads has gone and one element, see, one four corner one quad element is generated. This is called remeshing or mesh addition. And if you see here the mesh flow lines are not correct means just go and select this one. Mesh flow means the elements what you are going to create, that should be very clean elements. So you just replace this node to here and again go to the F12. That is for the mesh addition. Either you can go by selecting the window or by element to element also you can select. Say mesh. See, now it is done. See, now observe. See, this is, you just observe. There is a, this shape is not correct. Say mesh. How clean mesh is. See how clean mesh is now. One more time I'll do. See. Okay. Now the flow lines are not correct. So just I'm going to remesh this area by selecting the elements. I'm choosing this by window. Here also you can increase or decrease the nodes. See, if you are increasing or decreasing the nodes means just to adjust with the number of nodes to reduce or increasing the trias. So here 6 is there. Here also I'm making 6 just to match with the elements. So this is how you need to measure. So you can go, you can select all the surfaces and you can mesh that also. Choose the surfaces, say mesh. See, here also if you want means you can increase one number. See, the tria has gone. See, this is how you need to measure. So meshing means by going the FL panel also you can do, or else by going with the 2D panel, that is editing the mesh also, that is also done. So now we'll do one small rib here. So we'll mesh this rib. Okay, as I said, okay, I'm going to delete this element. This is not required for me. Okay, now I need to check whether all the elements are connected or not. And see, these are the necessary checks you need to do. This is very small element. So I'm going to delete this element. So after deleting, I need to merge this node till here. Why? Because to represent the geometry. Just observe. Here we cannot leave the element like this. We need to merge it here. Why? Because the original geometry is in a triangular shape. So I'm creating my elements based on the geometry. So based on the geometry only, we need to create the elements. Okay. If it is a triangular rib, I cannot create a one quad element. I need to end it with a triangular element only. If it is a rectangular rib or square rib means I need to go with the square elements only. I cannot end with this. I cannot end without any of the triangular element. These are the basic meshing ideas you should know. These are the basic meshing ideas you should know. Then after meshing that component, the component look like this. See, this is how the component, see, I have extracted the mid surface for this component. Keep it in a mixed mode. See, this is how it looks. I have assigned the properties also. In the overall component, it looked like this. So if you want to, after defining that quality parameters, after completing everything, after completing every meshing and all, after defining the thickness, your element should look like this. Your element should look like this. This is the original. See, this is a good mesh. I have created the elements. See, I have defined the properties also. So what is a property? So how to do that? I'll show you. See, this is the CAD which we are working. Now we'll review the thickness for this one to create the property. So how to review that means go for the mid surface. In this drop down, you can see the review thickness option is there. You click on that one and choose the surface, whichever you want. See, it will show the maximum and the average thickness. Since this is in rib, the maximum thickness is 1.7. The minimum it is varying between 1 to 1.4. It is varying. 1 to 1.4 it is varying. So according to that, you can create the collector. Then click on this one. See the overall cylindrical portion having 3 mm of thickness. See, it is showing from where to where it is taking. It will show from here to here. It is showing. It is 3 mm of thickness. And if it is a 3 mm of thickness, here property collector is there. You can see, if you don't know anything means you just go on, wait for 1 second here. It will show what it is meant, or else directly go here by creating a property. Okay, give some name for the property. I am creating the shell elements. So I'm creating one property called shell. The coordinate should be P shell. Why? Because we are creating the shell elements. Then here the T is there. That means thickness. So what is the thickness? Thickness is 3 mm. So I'm defining the thickness 3 mm. So after creating that one, you just assign that property to the particular component. Okay. After that one, if you can keep it in a traditional view, it will look like this. See, it means this component, what we have done, it is thickness is assigned. You just observe, I have kept it in a normal view. In the normal view, it looked like this. But if you keep it in a traditional detailed view, you keep it in detailed view and switch on the original CAD and check. See, it should look, it should capture it. We have to capture all the surfaces, this surface and this surface also. This is how you need to mesh, and after meshing that one, whether you have created the elements which are correct or not by assigning the property and the thicknesses, keep it in a detailed view and you need to review that one. See, exactly it is in the middle. I have created the elements, I have created the good elements and I have defined the property also. I can see my elements on the both the surfaces, but I have meshed on the mid surface. So this is how the mid surface works. Next is the quality parameters. So what are the quality parameters and why it is required? Basically, we have created some element. Okay, after creating the elements, it doesn't mean like, okay, the elements which I have created are 100% correct. No, it is not like that. Why? Because the geometry what we get, it is sometimes we may get a very smooth geometry. Sometimes where it is a complicated components also. Say for example, the interior panel, what we can see it in a car, those are the fiber components or plastic components that will be having more features. You just observe, I have a comparison between bonnet and the dashboard. That is the interior panel dashboard is there, no? That all your readings, recordings, there, no? That musical set panel, that is called the interior panel. We can call it in industry side. You just have a comparison between bonnet and this one. You can see in the bonnet, one large component is there, that is huge one, that is made of steel or aluminum, that is having a very less features. When it comes to the interior panel, it is made up of plastic or fiber components that is having more features. The clips will come, the any of the pressing components will come, sockets will come. That means that is having a more features, no, even though it is a plastic. So meshing for the bonnet is easy compared to the interior panel. Why? Because of the geometry. So what I can do, even for the critical components, I may fail to keep the 100% correct elements. So what I can do in that case, I'm having certain boundary limits. These are the quality parameters. Well, no matter what is the geometry is, I need to keep my elements within the quality parameters. So what are the quality parameters which we looking for 2D elements is, the main quality parameters are warpage, aspect, minimum and the maximum length, Jacobian, and the triangles for the quad and the triangular element. Why it is required? Sometimes we may fail to keep the 100% exact element. That means 60 degree triangular element and the 90-degree quad element. So that time we can go by changing some of the dimensions which are already defined in this. So what are those? We'll check it in HyperMesh. Keep it in a normal view. Switch off the original CAD. Just you can go by F10. You can see these are the defined values. See here, actually the warpage we need to set for 15 degree. Now the 15 degree, it is not failing. No, there are no elements are failing for 15 degrees. So I'm making for 14. And these numbers, no, don't stick to these numbers. These numbers will vary based on the element size what you are using and the project requirement and the type of analysis you are doing. All these, based on all these things, the quality number will vary. See, it is failing. One element is failing for 14 degree. My minimum, it should be, my elements, all the elements should pass the 14 degree. They say failed. I'll show. I'm going to retrieve only that element. Okay. Where is that element? We'll see. Okay, mask reverse. Okay, this is the element. You can see this is the element. So again, go for the F10. You click on this element. No, you just click on any elements in the F10 panel. See, I came for the F10 panel. That is the quality index for the 2D elements. I'm clicking on this element. It will show all the details. The warpage is showing 14.5. The aspect it will show, minimum and the maximum length, and the Jacobian, every details it will show. So what is and warpage means? See, warpage, you can see these three nodes are appearing. but this node is not appearing. You can see these nodes are appearing on the exactly on the surface, but I cannot see this node. It means warp edge means the node or the element is not being the planar. That means this node is not on the plane. The how much it is going out of the plane, that we need to pass that element. So warp edge means the how much the element is deviating from the plane. So I'm just increasing this one. Now again go back to F10 and check this one. See, now it is 8. Now it is within the warp edge. That is, it means it is within the defined quality parameters. So this element is passing now. This is the warp edge. Now all the elements are within the 14 degree only. And this is the important one. And the minimum and the maximum length, it will vary based on the element size you are using. And the aspect means, that means minimum to maximum element length. I'll show you. The one more quality clearing parameters is available in HyperMesh. Go for 2D page. Come for the 2D page. Here quality index is there. Come for 2D page. Click on the quality index. If you see, these are the sub panels are there. So as I said, aspect means minimum and the maximum element. See, you can see these element. No, what is the distance between these two nodes is 3. Here it is 8, 0.8. So this is wrong. This element, this I cannot keep this element. Why? Because aspect is failing. So how to clear this one? Go for the quality index. Just drag and drop the node. By dragging and dropping the nodes, you can clear the few quality parameters also. See, you can clear the few quality parameters. So this is how the quality parameters is works. Then one more is Jacobian. Jacobian means, see, ideally for Jacobian is it should be 100%. As I said, in all the way I cannot go with the 100%. So there are two elements are failing. See, this is the element. This is the element which is failing for the Jacobian. So that means all the way I cannot keep the exact 100% of the element. See, this element will fail for the Jacobian. That means it is not 100% exact quad. So what I can do, I need to clear this one means just by dragging and dropping the node. And one more thing, dragging and dropping the node means, okay, wherever you want, no, you cannot do that. The node should be within the boundary, within the surface, on the geometry. It should not come out of the geometry. And these are the main quality parameter, quality checks you need to learn when you are working on the 2D elements. So next, these are the additional quality checks. They shouldn't carry any duplicate elements. Why? Because if you are keeping any duplicate elements, it will add extra weightage to the component. If it is a more weight means, obviously there are less stress and we will deviate from the deformation plots. There should not be any, you should not be having any free edges, normals. And as I said, all your elements should be within the geometry only. These are the other additional checks along with the quality parameters you need to take care. Then next, in the last part, how not to mesh. Creating element means it doesn't mean like, okay, however the elements you want, you can keep. No, that is not the way. You need to keep the elements in a proper shape. That means there should not be any back-to-back trias. You should not be having any opposite trias also. You should not be having them. See, I have opened this file. As I said, we should how not to mesh. In the last sector, we need to know how not to mesh. Why? Because meshing means it doesn't mean like, okay, however we want, we can create the elements. This is the wrong way of doing the meshing. Why? Because in the corner of the geometry or in the end of the geometry, we cannot keep any trias. Why? Because see, tria will not, if I am applying any load to this component, tria will not take the load equally. So that reason we need to avoid the trias on the corner of the side. Then one more thing is, see, these are the opposite trias. So how to clear the opposite trias means either you can go by choosing the elements, that is do remesh. You can see this will pass, or else go for 2D quality index. You just drag and drop the node. See, I'm just bringing this one. See, this is the drag tria element is there. I'm just dragging this one. You can do that also. You can do, or else go for mesh. See, the mesh size is varying between these two, so it is not going. I'll just swap this one. See, If you want, you can swap and you can drag this trial. You can drag this trial like this. Like this also you can work. Then see, this is not the correct way. Why? Because this is not aligned. So how to align this one? Go for F7. So select the nodes, choose the nodes neatly and align this one. Say align. See, it is aligned. Aligning means I'm just taking the two nodes. This is the master nodes and I'm selecting the nodes which I want to align. Then say align. See, it is aligned. After that one more option is there by smoothing the elements. That means I need to correct the flow of elements. Why I need to correct the flow of elements? No, when I apply the load, when I apply any force load, temperature load, or whatever it is, it should take equally. So this is the reason we need to correct these things, and this is called the free edges. See, free edges means these nodes are not connected. See here, all the four elements are connected by this node. No, like this, all the nodes should connect. So how to do that? So like this, you need to connect this one. So like this, you need to connect. So these are the other checks we should take care when we are doing the 2D meshing. This is the opposite trias, back-to-back trias. See, one node is sharing between the two triangular element. This is also wrong. See, two trias sharing the single load means that is not, we are not supposed to keep that kind of elements. Always we should go with the good flow. This is the good flow and this is the recommended one. And trias and the fillet is not, we are not supposed to keep trias on the fillet section also. And as I shown in the edges also, near the circular section, that means any of the bolts or any normal holes are coming means we are not supposed to keep any trias. Why? Because it will not take the load equally. So this is the reason we are avoiding the trias. It is mandatory. And I hope I have covered all the videos, sorry, all the topics which I have discussed. Thank you. So by this, okay, next one, zigzag meshing is not allowed, and one is for the recommended for the crash analysis it is recommended. For this kind of mesh is not allowed all the way unless it is specifically mentioned. And I hope the topics which I have covered, you understood the topics on the 2D meshing, starting from editing the mesh to the creating the mesh, editing the mesh, and finally we have learned the quality parameters also. And I hope this video is well helpful for you guys. If you are having any queries related to the today's topic, you can ask in the chat box. I'll answer.